Good day everyone, I am Janil Cruz Ministerio and I am going to report the family of stars. Let us start with the objectives. These are the questions to be answered. How far away are the stars? How much energy do stars make? How do spectra of stars allows us to determine their temperatures? And how big and massive are the stars? Let us start in the distance of the stars. The closest star, Proxima Centauri, is 4.24 light years away. A light year is 9.4 trillion kilometers or 5.8 trillion miles. So napakalayo nga ng star na ito kahit ito na yung pinakamalapit sa ating galaxy. Kahit ang liwanag ay abuti ng halos 4 na taon bago pa ito marating. At ano pa kaya kung tayo mga tao yung maglalakbay patungo doon? Gaano tayo katagal makakarating? Astronomers used an effect called parallax to measure distances to nearby stars. Parallax is the apparent displacement of an object because of a change in the observer's point of view. So yun nga ang ginagamit ng mga astronomers sa pagkuha ng distance ng mga stars ay yung parallax o parallax effect, kung saan gumagamit tayo ng tatlong point upang malaman natin kung ano yung distance ng stars sa magkakaibang location. Ang tawag doon sa method na yun ay triangulation. May dalawang uri ng triangulation. Yun yung surveyor's triangulation at saka yung astronomer's triangulation. Triangulation is a surveying method that measures the angles in a triangle formed by 3 survey control points. Using trigonometry and the measured length of just one side, the other distances in the triangle are calculated. Let us go to the parallax and distance. Parallax is one of the most important distance measurement methods used by astronomers. It can be only used for nearby stars, but it is very accurate. This method works by measuring how nearby object appears to move against the background of more distant objects. So ito yung illustration kung paano ginagawa yung parallax method o yung pagsuri ng measurement ng distance ng isang stars gamit yung parallax method. So gumagamit sila ng dalawang position ng Earth sa magkaibang panahon. Halimbawa ay yung observations in August at saka yung observations in February, kung saan mas malayo yung position ng Earth from the star in August while nearer in the month of February. To be more clear, yung ginagamit sa parallax ay mas tinitingnan nila yung nasa likod ng mga objects o yung mas malayong objects dun sa sinusukat na star para malaman kung ano yung pinagkaiba ng measurement nila dun sa dalawang points. So this one is an example of simple parallax effect kung saan ginamit yung bundok upang ipakita yung distance ng mas malapit na bundok. Ang isa pang example nito ay yung kapag tayo ay bumabiyahe habang nasa loob tayo ng sasakyan, makikita natin na yung mga puno ay mabilis yung paggalaw dahil nga nalalampasan natin. Pero yung bundok na nasa mas malayo, hindi natin agad nakikita yung pag-change ng kanyang position dahil nga mas malayo siya kaysa doon sa mga puno. The next one is the two type of brightness, which is the apparent and the intrinsic brightness. Apparent brightness is the brightness of the stars that appear on Earth, o ito yung mga nakikita natin kapag tayo ay tumitingala sa, while the intrinsic brightness is the brightness of the stars due to the amount of energy it radiates, o yung dahil nga sa laki nito, ayan, halimbawa mas maliwanag siya kapag mas malaki siya at mas mahina yung nararadiate niya kapag siya naman ay mas maliit. Nagmamatter din dito yung layo ng mga stars mula sa Earth at makikita natin na kapag mas malayo yung stars, maaring mas mahina na yung makikita natin ng liwanag. The next one is the luminosity. Luminosity in astronomy is the amount of light emitted by an object in a unit of time. The luminosity of the sun is 3.46 times 1026 watts. Luminosity is an absolute measure of radiant power that is its value is independent of an observer's distance from an object. On the other hand, brightness is what we see, while luminosity is the amount of light emitted by an object or a star. The next one is the absolute visual magnitude. The absolute visual magnitude of a star is defined as the magnitude it would have if it were viewed at a standard distance of 10 parsecs or 32.6 light years. The apparent magnitude of a star as estimated by the human eye. The eye is capable of ranking stars in order of brightness and estimating equality between two stars or a star and an artificial source. From the word visual, yun nga ginagamit natin yung ating mga mata sa pag-rank ng stars o yung liwanag ng stars base dun sa ating pagkakatingin. At maaari din itong gamitin kapag nga nasa loob pa ito ng 32.6 light years away from Earth. The next one I am going to discuss is the stellar spectra. A star's spectrum contains information about its temperature, chemical composition, and intrinsic luminosity. Spectrograms secured with a slit spectrograph consist of a sequence of images of the slit in the light of a star at a successive wavelengths. The Balmer thermometer. The Balmer thermometer instrument namely uses spectral lines of hydrogen that are visible to the human eye. It is called Balmer lines and it is used to estimate stellar temperatures. Hydrogen lines. The strength of these lines in the spectrum of a star is an excellent indication of the temperature of that star. That is why the Balmer lines are often called the Balmer thermometer. This diagram shows that the higher the hydrogen lines, the higher the temperature of a star. This table shows the classes, temperatures, and the color of the stars. Class O ranges from 30,000 to 60,000 Kelvin, which has a color of blue. Class B ranges from the temperature of 10,000 to 30,000 Kelvin, and it has a color of blue-white. Class A ranges its temperature from 7,500 to 10,000 Kelvin. Their colors are white. Class F has 6,000 to 7,500 Kelvin, which are yellow-white stars. Class G has 5,000 to 6,000 Kelvin, and they are called yellow stars like the sun. Class K ranges from 3,500 to 5,000 Kelvin, and they are yellow-orange stars. Class M, which is the coldest among all the stars, ranges its temperature from 3,500 Kelvin, and their colors are red. Stars in the O class are the most luminous, hottest, and most massive stars, with temperatures above 30,000 degrees Celsius, while the stars in the M class are the coolest stars, with temperatures below 3,500 degrees Celsius. This table shows the census of the stars within 21 light years away from the Sun. There are two Class A stars within the 21 light years away from the Sun. There is one F class, 7 G class, 17 K class, and 94 M class. There are 8 white dwarfs and 33 brown dwarfs within this area. The next one is the sizes of the stars. Stars range in size from neutron stars, which can only be 12 miles or 20 kilometers wide, to supergiants roughly 1,000 times the diameter of the Sun. The size of a star affects its brightness. Specifically, luminosity is proportional to radius squared. Star temperature. The hottest one measures 210,000 Kelvin. The hottest known star is called the Wolf-Rayet star. The temperature of stars may vary according to their size and according to their color. There are 3 classifications of stars: the dwarf stars, the giant stars, and the supergiant stars. Dwarf stars are low-medium star with mass less than 8 times the mass of our Sun. Giant stars are any stars having a relatively large radius for its mass and temperature, because the radiating area correspondingly large and the brightness of such stars is high. while supergiant stars are the stars with a diameter of several hundred times of the Sun and luminosity nearly 1 million times as great. Supergiants are tenuous stars and their lifetimes are probably only a few million years, extremely short on the scale of stellar evolution. This picture shows how massive are the supergiant stars compared to our Sun. Luminosity spectral classification. Luminosity classes are labeled with Roman numerals from 1 to 5. 1 are supergiant stars, 2 are bright giants, 3 are ordinary giants, 4 are subgiants, and 5 are ordinary main sequence stars. The complete spectral classification for a star is then given by specifying both the spectral class and the luminosity class. Spectroscopic parallax. Spectroscopic parallax or main sequence fitting is an astronomical method for measuring the distance of stars. Despite its name, it does not rely on the geometric parallax effect. The spectroscopic parallax technique can be applied to any main sequence star for which a spectrum can be recorded. We can see in this diagram that the bluer the star, the higher its temperature, while if the color of the star is red, then it might have a lower temperature. This diagram also shows that the bigger the stars are, the higher its luminosity. Star masses, binary stars. About half the stars are binary stars, two stars that orbit each other bound together by gravity. Masses of a binary star can be calculated from measurements of their orbits, just as the mass of the Sun can be derived by measuring the orbits of the planets around it. There are three binary systems. Number 1, visual binary system. The next one is the spectroscopic binary. And the last one is eclipsing binary. The mass and luminosity relation. The luminosity and temperature of a main sequence star are set by its mass. More massive means brighter and hotter. That is all. Thank you for listening.